Hi, hello friends. Welcome to the today's session. Today we are going to discuss the very important topic that's called CIDR. What is CIDR? It's nothing but classless inter-domain routing, which we are mainly using in configuration of routers and internet service provider IPs. Especially the CIDR is mainly used in ISPs, nothing but internet service providers who are going to give you public IPs. In today's session, we are going to focus on CIDR, how the address notations and how the subnetting in CIDR is taking place. So, before entering into the lecture, let us say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. About myself, Srinivasrao IS, having more than 15 years of experience in the various subjects of computer science, also had industry experience with a relevant good certifications like a networking side and operating system side as well as a database side. You also can achieve all these things by having a good training from good professionals which are offering by Unacademy. So, my dear friends, throughout the journey, my journey in the gate, I taught in many premium academies, and the success rate is very high, which including of single digit ranks. So, you also can be. Many of my students are alumni of IITs and NIT central universities. They're also working in the topmost MNCs as a topmost software professionals. Some are in cryptography side, some are in database side, and some are in blockchain and artificial intelligence side. You also can be just by taking a proper guidance and proper training. All you need to do is take the admission in an academy, either 12 months or 24 months, then achieve the benefits whatever our earlier alumni got. So all you need to do is get the admission in an academy. You can also get the maximize discount if you are applying my referral code. The referral code is Sankara. So if you are applying my referral code, then you are going to get the maximum benefit while you are taking the subscription. What the subscription will give you? Subscription will give you live classes, live quizzes, and recorded classes, whatnot, everything which are very useful to clear your gate examination or any kind of campus placement interviews. So, dear friends, as we know, without investment, there are no returns. Take the admission in an academy, use my referral code, and get the benefits which are there in the portal of an academy. Let's Crack Gate CSC is our YouTube channel. Subscribe that and use my referral code to get the maximum discount. Once you get the admission in an academy, then you are going to be called as a plus student or iconic batch student. An academy recently launched the iconic program. There the students are going to get much more benefits, which inclusive of plus courses as well as many other opportunities are there if you become a student of or subscribed student of iconic batch. So these referral codes are eligible for all the courses which are there in an academy. You can get the benefit of get the benefit of discounts when you are taking admission. So dear friends, let us start. What is CIDR? If you are saying a CIDR concept, the before lessons or before lectures, we understood as per as IP addressing concern, there are two varieties. One we land classful and the other one we land classless. Classful in the sense there are a fixed block size, like A is having a fixed blocks, B is having a fixed blocks, C is having a fixed block, D is for a different purpose, E is for different purpose. So when you are talking these three, that means the block sizes are fixed as well as number of blocks are also fixed. Therefore, what the classless is saying, we are not going to concentrate on any octet to be called as that your belongs to so and so class, because every number you talk from 0 to 200 and to 255 which is offering by your IP octets, all are going to be called as numbers only. They are not going to be called as a classes as like classful addressing. So what are the problems with the classful addressing? The problems with the classful addressing is nothing but what? Reservations in each class. That means A is reserved with a 1 bit, B is reserved with a 2 bits, and C is reserved with 3 bits. D and E are reserved with 4 bits. Therefore, your block sizes are going to be reduced, and hence the wastage of host IDs. That's why what the classless is saying, there is no concept of such kind of reservations. Simply, we are using the concept of what? Classless IP addressing. So number of routing entries are also very less when you are talking about the classless as comparatively to classful. So how this is to be done and what is the notation we will look at in this. So when I am saying some number here, I am saying one number such that 192.168.100 is something like 0. If I am talking that it is a class full, then you need to address three important things. The first octet value belongs to, you know, the ranges, that is 0 to 127 and 128 to 191 and 192 to 223. You will be in a confusion whether to remember these numbers. So while configure your IP addresses, you are supposed to maintain this list so that you can able to switch the particular computer in a proper classes. Otherwise, it's a meaningless. That's why in order to remember or in order to do this process, simply we are using the concept of what? Classless. Any number you can keep in anywhere. I don't mind. Understand? I don't mind because everything is defined using a what? Slash n. What the meaning of n? N will says that number of ones in the subnet mask. A number of ones in the subnet mask which decides that how many bits are for network ID and how many bits are for remaining host IDs. But as far as class A, if I am designate that this is the class A, please understand carefully friends. If I am class A, you know the format. What is the format, my dear friends? So the formation you also need to remember N and triple H. This is as far as A concerned, and double N and double H as far as B concerned, and triple N and 1H as far as C concerned. That means your network block sizes and host sizes are being classified according to your class only. So you need to remember two important things in the classful. One is what is the octet value of the first octet, and the second is if you know the corresponding classes, then immediately according to the classes you need to identify host IDs carefully. That's why we want to full stop this kind of addressing mechanism. It is okay as far as smaller computers concerned, that means what small groups concerned. But when you are talking about the ISP, Internet Service Provider, who is managing huge thousands and lakhs of IP addresses, how is this possible? That's why we are not going to switch over. Last session I shown you very clearly what is that? How to switch over from C class to B class and how to switch over from B class to A class I shown you. So this switching mechanism you need not worry while you are talking about the classless. So what is the switching mechanism I said? The switching mechanism to move from one lower class to upper class is nothing but when I am talking that class C, you can able to have the maximum of 256 HIDs only, not more than that. So your requirement is greater than this 256, then immediately need to switch over to class B. And the class B can maximum will give you 65,536 host IDs only. You want to go for more than that, then you're supposed to switch over to class A. Therefore, my dear friends, how we are jumping from lower classes to our class, so just to acquire more number of host IDs only. This switching mechanism is not there in classless. What the classless is saying, everything is in the form of slash n only. When I am saying that, for example, slash n is nothing but, when I am saying slash 8, what's the meaning of 8? 8 ones. When I am saying slash 16, which is nothing but 16 ones. When I am saying slash 24, which is nothing but 24 ones. So this is how we are going to designate your subnet mask. So what is your subnet mask? If you want me to write a meaningful subnet mask according to the classful IP addressing, now I am writing 8 ones is nothing but your suitable subnet mask as per as our previous discussion is this only. In this there are 8 ones are there. If you are talking a 16 ones, then your suitable mask is a 255 and 255 0.0. So 16 ones are there in this. As far as 24 ones concerned, I am saying 255 8 ones, 255 8 ones, and 255 8 ones, and the remaining are going to be zeros only. So my dear friends, this slash n format will tell you that how many number of ones or network IDs. That means what, the ones are belongs to n IDs only. How many ones are for network and the remaining are going to be what? Your host IDs only. So I don't mind any kind of octet I am going to give you. For example, I say 192.100.100.0. I am saying that slash 17. Yes, you can give it. Or actually, if you are looking at the class full, as I am saying that 192, if I am talking in the form of a class full IP addressing, then I can able to say that it belongs to class C, and class C can maximum will give you only 2 power 8 HIDs only. So how much it is? 256. But if I am talking this into classless, if I am talking this into classless environment, then what is going to happen? How many HIDs are there? You can easily interpret this value. How many? There are 17 ones out of 32 IP block. So 15 ones are 15 bits are for zeros only. That means 17 are ones and remaining 15s are zeros. So I can able to say that 202 power 15 and minus 2 host IDs we have. See that. In a class C, if you are limiting the class C, then you are limiting to 256. But as I am not following any kind of classes, simply I am enlarging and decreasing as per as my own requirement. See that the beauty with the class C, same class C capacity, but I would able to generate more number of host IDs. This is the advantage with CIDR because I am not talking a concept of a class. It's nothing but one number. 192 is a one number. I'm looking that the size of your blog, I'm looking only in the form of what? Slash n only. So here you forget about the octet value, octet 1 value. It may be 192, it may be a 10, it may be a 172. We don't mind. We are going to see only what? How many ones are there, because it is not following ABCDE classes. It is universal class mechanism. When you are talking universal class mechanism, a number can have any number of HIDs as per as simply saying slash n format. Well friends, observe now how this is to be done. I am saying three formats I will give you. Slash 8, 8 ones. So in exam you may ask you meaningful masks. You need to know the meaningful mask also. Second format I am giving you slash 16, 16 ones. 255.255.00. If I am giving 24 ones, then you can able to have a 255.255.255.0. Now this is equivalent to A. I'm trying to put it in the form of classful of your classless representation. This is representing to B and this is representing to C. Well, friends, so apart from that, I can have other formats also. What are the other formats? I can say /18, I can say /20, I can say /n. So these formations are not there in your classful. This is the specialist IP addressing in the CIDR. So where to use CIDR? When you are talking about the CIDR concept, where the CIDR is going to be implemented and used, especially while configuring internet IPs. When I am talking about the internet IPs which is given by your ISP, you know that internet IP must not be duplicated. Must not be duplicated because it is universal. Universal unique we need. Because your google.com is configured with internet IP only, nothing but public IP. So that's why the public IPs must be unique. When I'm saying the concept of a public IP, so public IP configuration we are going to do with the help of CIDR only. And we are going to avoid the limits, avoiding the limits which are in classful, as it is a what? Classless, any number you can able to keep. And because of these advantages, routers are following router's IP configuration is based on CIDR. Please observe carefully, friends. So these are the benefits of your CIDR. Apart from that, in CIDR you can able to do subnetting also. That means what? Subnetting chances in CIDR. Subnetting chances in CIDR you can do. And the block sizes can be increased. Block sizes can be increased, can be decreased just simply by saying what is that? /n. But in that, block sizes can be increased and can be decreased by doing a what? Switching over from one class to other class. Here there is no concept of interpretation of classes, it is a classless concept. That's why block sizes as per as your requirement you can able to do increase as well as decrease, as we are not sticking on to your classes. There your block size is decided by your classes only, but your block sizes can be dynamic, which is deciding by your /n formations. So now let me tell you few examples about CIDR. When I am saying the example like this, I say 100 point, 100 point, 100 point, 90/17 I am saying. So what is the meaning of number of HIDs in that? How many HIDs you can able to post in that? That simply you can answer my question like this. So total IPv4 if you are considering it is a 32-bit, we know 32-bit is nothing but you are going to get 2 power 32 concept minus in that how many are there? 17 ones are there and remaining are going to be what? Zeros only. So your number of host IDs according to /n format is 2 power 15 minus 2. So it may be any kind of notation. So I'm not talking about any classes here. If I'm saying, for example, 200 notation I'm following 200.200.100.100, I'm saying /8. What's the meaning of /8? So 8 ones are there. So he is asking, please give us a number of HIDs in that. Yes, I can give number of HIDs. How? Your 2 power 32 minus 8 ones are there and the remaining are all going to be what? zeros only. So these many host IDs are there with you, my dear friends. Observe carefully. So using that, I can able to find the block size. That means what? Start of the block and end of the block. Nothing but your as like your last session. So now I want to find the starting of the block address and ending of the block address by taking an IP. I'm saying let IP is 200.129. Now we want to find out few questions. Number of HIDs. This is the first question. Second question. So if you know number of HIDs, I will come to know what is my block size. Block size is nothing but how many number of hosts you can able to keep it in that particular partition. And now I am asking what is your starting block number, what is your ending block number? Because you are not going to utilize as your normal IP addresses starting of your number and ending of your number. So he is also asking starting CIDR block number. Starting CIDR block number as well as ending CIDR block number. So my dear friends, observe carefully how to solve this bit. First question already we are aware of it. All you need to know that what is a slash information. Now I am giving you slash 15. So now the first question we are going to solve. Solution for the first question. And he is asking number of HIDs. It's very simple, 2 power 32. There are 15 ones given in the format. Therefore, you are having a 2 power 17 minus 2 HIDs. No doubt. He is asking starting CIDR block number. How to obtain? This is very important question. So, how to obtain block number of CIDR? Block number of CIDR of the given IP. What is the IP given to you? 200, 100, 100, 129. So 200 and 100 and 100 and 129 is your number. And he said that slash 15. This is how he mentioned. 15 is nothing but 15 ones and 17 zeros. My dear friends, in that 8 ones are there. In that 8 ones are there. Now remaining all are zeros because we want 17 zeros, right? Because 2 power 32 minus 15 is nothing but 2 power 17 zeros we want. So 16 zeros are in this and 16 zeros are in this. So one bit is there in that. Now you please write the binary, the particular octets. What are the octets I supposed to write in the binary? This is HID part. This is also HID part. In that, one bit is HID, remaining all are for what? NID only. So my dear friends, this is NID and some of the bits are there is NID also. So NID we are not going to touch. NID is nothing but network ID. So your block number of the given IP is nothing but write this 200 as usually because no manipulation is done. Here manipulation is done. So write your 100 in binary. Here manipulation is done. Write your 100 in binary. So this is a host ID part. Write 129 in binary. Now you decide what is your host part and what is your NID part. NID is a 15 bits. So take your 15 bits left to right. Now your rest of the thing is your HID part only. So 17 zeros I want. Exactly. It is the division. Now you want block number. We know the policy. What is the policy? Make HID positions to zeros only. Make HID positions to zeros like this. First. And you want block broadcast address ending number. Same as it is 200 point, as this is NID and this is also NID. Up to NID bits you write as usually. Remaining you make them to what? To want to broadcast. What is required? Broadcast is nothing but all ones we want to do. So these are all becomes ones. All ones means 255 and all ones means 255. Now we got our answer. What is our answer, friends? Your block number is 200 point. What is the value? 96 plus 4, 100. What is this value? 0 and 0. This is your block starting number. What is a block broadcast? This is 200. Please understand carefully. This is 96 and this is 4 and this is 1. So how much it is, friends? Observe carefully. This is 96, this is 4 and this is 1, which all together 101. And ending number is what? 255 to 255. So this is how you have to obtain block broadcast address and block number. Now you see another example. I'm saying this example as like this. 200 point and 100 point and 100 point 96/20. He's asking all the three questions. What is that? Find number of HIDs, comma, block number, straight away I'm asking, and block broadcast address. We know that this is a CIDR because of this representation. Now number of HIDs is asking, we know 2 power 32 minus 21s are there. Therefore 2 power 12 minus 2 HIDs. This is your answer. It's nothing but 4094 HIDs you are going to get. Now you listen, friends. Second question is asking block number and block broadcast. You want to know block number and block broadcast. You see that how much is NID part and how much is HID part. So here 20 ones means 20 networking numbers. Therefore 200 8 ones are there. It is NID. 100 8 ones are there. This is also NID. And this 100 8 bits, but we want only 4. Why? 8 bits are in this, 8 bits are in this. Total I want 20 ones. So 4 bits I will take from that, and 96 is your host part only. So this part consists of what? Network ID as well as HID part. Okay, friends. Now he is asking a block broadcast number. You need not write this into binary because already it is a what? Only purely networking number. But this octet I need to write in binary to get the block number. So your block number is, as it is, you drop 200 and 100, write 100 binary. 011000100 and write 96 binary. 011000000. So now, friends, observe carefully. So HID positions we want to identify. So the last, if you guess, last 8 bits we want to keep it for HID. And one more, because 20 bits are NID, that means what? 12 bits are for your HID, because 32 minus 20, our concentration is at 12 bits for HID only. So 8 bits are here and 4 bits I am going to get from third octet. Now where is the boundary? The boundary between your NID and HID is this only. This is your NID, this is your NID, this is your NID. These 4 bits are HID, these 8 bits are HID. You want to know the block number. What are you supposed to do? Simply make them your HID bits to zeros. Remaining you drop them. So they all becomes zeros and they all becomes zeros, as we know. Starting block means just you need to convert. Keep all the bits off. And you want block ending number, keep all the bits on. What is on? So I am making all HID bits to on. So my dear friends, your answer is 200 point, 100 point, drop as it is this. So what is your answer? Now you got the answer. What is that? Let me write the decimal number now. You see 200 point, 100 point, and this value is 96, remaining all zeros only. Therefore 96.0. And what about this value? 200 point and 100 point. This is crucial. 96 is here and 15 is here. So 96 plus 15, it is a triple one, and all 8 bits, it is 255. So this is your block broadcast number. This is how you need to calculate. And now my question is, this is my question. So here I am not going to look at that you are using 1 to 126 or 128 to 191 or 192 to 223 or 224 to 239 or 240 to 255. I am not looking like classes. Any octet is eligible for slash n format. But my question is, this is my question. Every block is eligible for CIDR representation. Every block is eligible for CIDR representation. Question mark. We will say that not. Because you want to represent CIDR, you need to be very careful. Few important rules are there in CIDR. What are the rules of CIDR? In order to say that I can able to follow CIDR means you need to follow 3 important rules. So what are the rules of CIDR? Rules of CIDR so that whatever IP I am keeping, that IP can able to follow CIDR representation. That's why there are 3 important rules are there. One rule, IP addresses must be consecutive. IP addresses must be consecutive. This is a very important rule. You cannot give odd IP addresses to represent CIDR. It should be in a contiguous fashion. And what is the second one? The size of the block. This is very important. The size of CIDR block, size is nothing but number of HIDs only. Please understand, friends. The size of CIDR block must be represented in 2 powers. Must be represented in 2 powers. Nothing but log base 2. Exactly it's supposed to. And the rule number 3 is that starting block number, I already told you how to bring the starting block number by making HIDs to zeros. Starting block number must evenly divisible by size of the block. Must evenly divisible by size of CIDR block. That's it, friends. Now I will train you how to satisfy these 3 rules then you can able to prove that whether it is a CIDR representation or not possible to represent CIDR. Now I'm saying, for example, 192.168.100.100 and 192.168.100.101. Please see, I'm giving some addresses to you. 192.168.100.103 and 192.168.100.106. By taking this address, can I able to put it in a CIDR formation? This is the first question. The above pool of IPs are eligible for CIDR. We will apply all the three rules. Rule number 1. IP addresses must be consecutive, but this is okay, but this is not okay, this is not okay. Therefore, not possible to represent in CIDR because rule number 1 is a what? Failed. Please understand. Not possible because rule number 1 is a failed here because IP addresses are not in consecutive fashion. Now let me tell you another rule. For example, I say IP addresses are 192.168.100.100. I'm not following a class full, I'm following classless only. So 192.168.100.101. So I'm following consecutive manner 103 and 104 and 105, 106. Rule number 1 is perfectly satisfied here. Now I am asking, is it eligible for CIDR? Is the above IPs eligible for CIDR representation? I will say no. Why no? Rule number 2. Let us satisfy rule number 2. First, rule number 1. It's a paka. Rule number 1 is satisfied because IP addresses are in consecutive manner. What about rule number 2? Rule number 2 is that the size of your CIDR block, size is nothing but how many host IDs are there in that. How many are there? This is 1 and second IP, third IP, fourth IP, fifth IP, sixth IP, seventh IP. So 7 IPs are there. So therefore log base 2 7. It's not representing in powers. I need to take the ceiling. That's why it is a what not possible. If it is 8, I can say that yes, it is a possible because I can able to represent in the form of 2 powers. 2 power 3 is nothing but 8. But here I am unable to represent the 7 in the log base form. Hence, it is not at all possible to put it in the form of CIDR. Now, I am saying one more thing. Please observe carefully. The example is 192.168.100.1 and 2, 3, 4, 5, 6, 7, 8. Now you got the point. What is that? Is it a CIDR formation? Rule number 1, we will cross check. It's success. All IPs are consecutive. Rule number 2, also success because your block size is 8. 8 means I can able to put it in the form of log base 2 of 8. So I can able to write in the form of 2 power 3. That means 3 bits are for host IDs. So you are going to get 2 power 3 host IDs, which is nothing but 8. What about rule number 3? Rule number 3 is that first IP address must evenly divisible by your size of your block. What is the size of your block? 8. So 8, 1 cannot be evenly divisible by 8. That's why rule number 3 is failed. Otherwise, my dear friends, how to satisfy rule number 3, I will tell you, observe carefully. What is the meaning of evenly divisible? Remainder must be 0. Here my starting number is a what? 1. My block size is how much? 8. So 1 divided by 8, is it evenly divisible or not? And if I am taking this is the first number, for example, if I am taking 2 is my first number instead of 1, so 2 divided by 8, is it evenly divisible? Remainder is 0 or not? This is how you need to check. Otherwise, I'm going to give you a hint that your first IP address, the last 3 bits supposed to be zeros because you are using a 3-bit host ID confirmation. But here if you are taking a 1 in the binary, the last LSB is a 1. So I am not seeing the rightmost 3 bits are zeros. Therefore, it's not eligible. So my dear friends, this is also not eligible. This is also not eligible. And this may be because 100, this is also not eligible. And this is a 101, 5 means. I am saying that last 3 bits must be zeros because you are following a 3-bit host ID. So this is not eligible as a starting number. And this is not eligible. This is not eligible. This may be eligible because 8. 8 may be eligible because 1000. So my dear friends, if you take the 8 as your starting number, then you are a success. That means you're supposed to have a numbering 8, 9, 10, 11, 12. But it is not accepting 1 to 7 as it is not evenly divisible by your size of your block, which is nothing but 8. Otherwise, the last 3 consecutive bits are supposed to be what? 3 here. That's where rule number 3 is got failed, and I will confirm that it is not following a CIDR. Now let me tell you the final example. All 3 rules I will make it satisfy. So 192.168.100. I'm starting this time 0. 1, 2, 3, 4, 5, 6, 7. Now let us cross check. Rule number 1. Success. All IP addresses are in consecutive. Rule number 2. How many host IDs are there? 8 host IDs. Can able to put it in 2 powers perfectly. That means you are taking 3-bit host ID representation. That means rule number 3. What is rule number 3? First IP address must evenly divisible by 8. Yes, exactly. Your remainder is 0. Otherwise, the last 3 bits of your octet, that means 0 is nothing but there are 8 zeros, my dear friends. Observe. There are 8 zeros. Therefore, the last 3 bits are zeros because I am following a what? 3-bit HID. Hence, it's a perfect. Rule number 2 followed. Rule number 3 followed. Hence, I can say that the above is eligible for what? CIDR. It's a perfect. So, how will you write the CIDR? This is very important. How to write a CIDR as you are eligible for CIDR? How to write a CIDR block? How to write a CIDR block? Very simple. Take your starting address. What is your starting address? 192.168.100.0 slash how many ones? This is very important. How many ones? So how many ones means tell me how many zeros you are using. I am using a 3-bit zeros out of 32-bit IP addressing, my dear friends. So 32 minus 3, then you got 29 ones here. Clear, my dear friends? So 29 ones I am following, 3 bits I am using only for host only. So this is your final CIDR block. This is your final CIDR block. Okay, my dear friends, take this block. We will find number of HIDs now. So I am taking that block once again. I will do reverse engineering. 192.168.100.0 slash 29. This is your CIDR block. Now he is asking find the number of HIDs, comma, starting block number as well as ending block number. I want to find ending block number is nothing but what? Block broadcast address only. Now let us find number of HIDs. We know 2 power 32 minus 29 is nothing but 2 power 3 minus 2 HID. So 8 HIDs we got. And minus 2 we are not going to use. One is for starting block number, one is for ending block number. Question number 2, starting block number. What is the starting block number? Write your IP now. What is your IP? Question number 2 I am solving. 192.168.100.1234567 Write your 0 in binary because 29 ones are there in your block. So 8 ones in this, 8 ones in this, 8 ones in this, 24 ones. Still I know I need 5 more ones. So 1, 2, 3, 4, 5. These bits are for NID only. So the last bits are for your what? HID part. So we got confirmed. Last 3 bits are HID part only. So you got 2 power 3 HIDs. Starting block number you want. What I said? Drop as it is. 192, 168, 100.12345. Drop NID as it is. Write HIDs to zeros. Already they are zeros luckily. And write HIDs to ones to get the block ending number. So we got 192, 168, 100.12345. What is your answer? You got the now answer. 192, 168, 100.0 is a starting number. Ending number 192.168.100.111 is nothing but 7. You got it? What is that? Please see that. I got this only. Starting number 0, ending number 7. That's why if you able to put the starting number in CIDR representation, then you can able to use the host IDs properly and effectively from starting number to ending number. So using the reverse engineering, I could get what? Starting number as well as I also could get ending number. So you can have IP address assignment to 8 host. In that 2 cannot be used. So you can able to use only for 6 normal IP addresses because starting number is your block number and ending number is a block broadcast address. So you cannot use those 2. You can use only between 1 to 6 host IDs only or IP address. This is how to represent your CIDR block. So let me write one more example. I'm saying friends 200 point, 100 point, 100 point, 97 slash 18 is asking write the pool of IP addresses. Pool of IP addresses you write in that. Pool of IP addresses means, my dear friends, starting number to ending number. He is asking indirectly. If I know the starting number and if I know the ending number, I could know the remaining numbers. So you know how to find the starting number and ending number, right? So 18 ones, 18 stands for 18 ones, 8 ones here, 8 ones here, 2 ones are here. So we don't mind about this 200, we don't mind about this 100, but this 100 consists what? Some bits are NID, some bits are HID, and the last bits are purely HID only. Because you want 18 ones. Already you got 8 ones, 8 ones, 16 ones I got. So remaining 2 ones I need to get. Write 100 in binary. So 0, 110, 0, 100, 97, 0, 110, 0001. Now you take those 2 bits also. So 8 and 8 and 2 bits are here. They are all meant for NID and leave the remaining part. So these are all NID and the rest of the bits are for HIDs. You know how to put the block starting number. What is the starting number? Your block CIDR starting number is 200.100.01. All HIDs you make them to zeros. And all HID bits you make them to zeros. and you want this block subnet address, then write everything NID part as it is, write remaining into ones. Bus friend. So you got your answer. These many IP addresses you can give starting 200 point, 100 point, and 01 stands for 64.02. This much big one, 200 point, 100 point, 127.255. These many hosts you can able to assign. So starting number 64.0, ending number 127.255, we will not use them first and last. And what are you going to use them? Let me write now. So 200 point, 100 point, 64.12, 200 point, 100 point, 127 point, last but not, that is a 254. These are all useful addresses only to you. Okay friends, so from here to here is your block starting numbers and ending numbers. See the advantage, very simple formation, but I can able to generate what? Host IDs. I'm not looking at any kind of octet, and I'm not limiting the IP addresses blocks and IP addresses size of the blocks. Everything is under dynamic only. But you can also do subnetting in this. Before you say subnetting, let me give you the another example. I'm saying 100 point, 100 point, 100 point, 130 slash 20 is asking, is this valid CIDR representation? Is this valid CIDR block? Question. Very important question this is. You know how to prove this. 3 important rules I said. IP addresses must be consecutive. Here there are no consecutive IP addresses. Leave it. So we assume that it is satisfied. Rule number 2. The size of host IDs must be represented in the form of 2 powers. Yes. Rule number 1. We assume that by default it's satisfied. Now you observe carefully. Rule number 2 is nothing but the size of the block size of your IP addresses must be represented in 2 powers. Yes. Your total IPv4 block is 2 power 32. In the 20 ones are there. So 2 power 12 HIDs. Fine. It's a fine. It's satisfied now. Because I could able to put it in the form of 2 powers. And what about rule number 3? This is a crucial. This is crucial to prove that whether this is eligible to starting number of your CIDR. If this is the starting number of CIDR, then I can start with this. Otherwise, you cannot start with this. He is asking indirectly, this 130 is eligible as a starting number. That's what he is asking. Is this valid CIDR block means the starting number I want to start with 130. Is it possible or not? Let us see how. Your 130, the first IP address of your block must evenly divisible by your 2 power 12. That is nothing but 4096. It's very difficult to do divisible like this. That's why I give you hint. What is that hint, friends? The last 12 consecutive bits must be zeros. Then it is eligible. Otherwise, it's not eligible. So 12 bits we want to see. 12 bits means 8 bits here, 4 bits here. They are all supposed to be zeros only. You want to represent that, that is 130 is a starting number. So it is not possible. Why? Please let me write this. So 100 point, 100 point. If I am writing this 0110 and 0100, 130, 128 and 10. So 128 plus 2, 130. Therefore, what happened, my dear friends? This is your 130 and this is your 100. Please understand. Rule number 3, what is saying? The first IP address, the last 12 bits must be what? Zeros. Are they? If yes, it's eligible. Otherwise, no. It's gone. It's gone. last 12 bits are not consecutively zeros. Hence, this is not eligible as a what? Starting number of your CIDR block. So this is how you can say what may be the starting number. Can you guess what is the starting number? Can you guess what will be the starting number of this block? Anybody, those who are online can answer this. What will be the starting number of this question mark? What will be the starting number of this? Very simple. I already told you. What is that? You make all HID bits to zeros. That's only your answer. So therefore, up to here it is HID. This is HID. This is also HID bits. You make them all zeros only. So my dear friends, you got the answer. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So these are all common. So brought down 0, 1, 1, 0, 0, 0, 1. So what is your answer? Your answer is starting number is 100.0. Then it is eligible for CIDR. So what is the answer? Please write now. Starting number 100 point, 100 point, and this value completely I am writing 100 point, and after making this becomes zeros. Please understand 0. This is your starting block number. If I give this with this 20 formation, then it's a perfect. It is eligible for CIDR. So this is a very important question, friends, in the exam. Let me give you one more question. Please observe these sort of questions carefully. 2020, there is a gate bit on this. Now you see 100 point, 100 point, 100 point, 96 slash 28. Observe carefully. Now he is asking, is this eligible as starting address? Please understand, as a starting address of CIDR. We will say yes or no by taking 3 rules. Rule number 1 perfectly हो जाएगा. Rule number 2, देखो 2 power 32 minus 28, 2 power 4 HID is perfectly satisfied. Rule number 3 question mark. Now we need to check. I said, what is that? 4 bits you are using for HID. That means what? Last 4 bits of your IP is supposed to be zeros. So let me write last 4 bits. So we are not interested in first octet, second octet, third octet, because host ID position is only 4 bits, remaining all network ID only. Now write 96. 0, 1, 1, 0, 0, 0, 0, 0. So 4 bits only for HIDs. It's a perfect CIDR. Now you understand, friends? All the last 4 bits are zeros. Now answer is a what? We will confirm it is yes. This is the starting number. What will be the ending number? Can you guess? Can you guess ending number? Guess ending number. I know the starting number. Ending number is nothing but make them to ones. The HID positions make them to ones. This is only ending 1. So 0, 1, 1, 0, and this is a common, and this is a common, and this is a common. So starting number is a 96. 96 plus 2 power 4 minus 1, 15. Ending number is a what? 1, 1, 1. This is your answer. So 100 point, 100 point, 100 point, 111 is your ending number. Well, friends, now this is what is the meaning of CIDR representation. You can increase or decrease your IP addresses, which was not possible in a classful IP addressing. You need not remember any octets, any range of numbers. It's completely dynamic. Now, how are you going to do subnetting in this? Subnetting in CIDR. So how are you going to do subnetting in CIDR? This is very important. For example, I want to take the previous example only. starting number 96, 100 point, 100 point, 100 point, 96 slash 28. He is asking do 2-bit subnetting. Please observe carefully. Do 2-bit subnetting. So when you are doing a 2-bit subnetting in that, please understand 28 ones are there. That means 100 point, 100 point, 100 point, 8 ones NID, 8 ones NID, 8 ones NID. So 24 ones over. Still 4 ones I need. Write 96 in binary. 0 1 1 0 1 2 3 4. This part is your HID. And this is a completely NID. Please understand. Understand, friends, it's a tricky concept now. I'm going to teach you. Observe carefully. When I'm saying in that I want to do 2-bit subnetting, in that you want to do 2-bit subnetting, you please see that this bit is under subnetting and this bit is under subnetting. So subnet and this is also subnet. So 2-bit subnetting you are going to get 2 power 2, 4 blocks. 4 CIDR blocks you got. What are the 4 CIDR blocks? Now this bit is HID, this bit is HID. Observe carefully. What are the 4 CIDR blocks? Now I will write 0 0 1 combination, 0 1 another combination, 1 0 another combination, 1 1 another combination. For every combination, these two are your HID bits. These two are your HID bits and slash. You drop everything as it is. So 100 point, 100 point, 100 point. Because they are LNID, we are not going to touch. Brought them as it is. 100 point, 100 point, 100 point, 0 1 1 0. This is also 100 point, 100 point, 100 point, 0 1 1 0. Now write the block numbers. What are the block numbers? The first block number starts with this. So 100 point, 100 point, 100 point. All together you read this value 96. And the next block number you observe. So this is 100 point, 100 point, 100 point. What is the value? 96. And this is 1 2 4. 96 plus 4, it is 100. And the next CIDR block number 100 point, 100 point, 100 point, 96. And what is the value? 1 2 4 8. This is 104. And next one 100 point, 100 point, 100 point. What is the value? This is 96. 8 plus 4 12. 1 2 4 8. So 96 plus 12. 108. So we got every particular subnet we got 2 power 2 HIDs. Please understand. Every block we got 2 power 2 HIDs. That means 4 HIDs you are going to get in every block. So 96 to, now I am going to write the range. 96 to 99. 4 HIDs. 96, 97, 98, 99. Bus. Next one. 100 to 103. 100, 101, 102, 103. So 4 HIDs in that. Next 104 to 107. Before this number only. 4, 5, 6, 7. 4 HIDs. 1082. Last number you know. So 8, 9, 10, 11. So 111. So in that you can also do a subnetting. Please understand. Come to the previous example. Starting number is a 96. Ending number is a what? triple one. We also got the same. What is that? Starting subnet number is 96. Ending I am reached to 100. In that I made 4 different parts. What are 4 parts? That is right. This 100.100.100.96 is now under subnetted. 100.100.100.96 is now subnetted, which means /28 NID bits plus 2 bits are for subnetting. So you got the new value, that is 100.100.100.96. It is 30. Why 30? Only 2 bits for HIDs. Please observe. Only 2 bits for HIDs and 2 bits for subnetting, and remaining 28 bits are for NID only. So now I got 4 blocks from this. I got 4 blocks from this. Write the block numbers. I got the subnet numbers in CIDR representation. First block 100.100.100.96/30. We have to write 30 everywhere. Next, second block 100.100.100. Second block is 100/30. Third block is 100.100.100.104/30. Next 100.100.100. This is 96, 100, 104, 108/30. That's it, friends. So you got 4 CIDR subnetted blocks. They are not a single block. They are subnetted blocks. And each block can able to have 4 IP addresses. 96 to 99. Please see, 96 to 99. And the second one, starting number 100 to 103, 4 IP addresses. 104 to 107 IP addresses. 108 to 111 IP addresses. Now let me do the same one more time before closing this. I'm saying 200.100.100. This is one of your GATE question, and 100/17 I'm doing. He is asking in that do 8 subnets. 8 subnets I want. 8 subnets means I need 8 subnet parts. That means 3-bit subnetting you have to do. 3-bit subnetting. In the HID part, 3 bits this time reserved for what? Subnetting. Now let me do. What is your NID? 17 ones are there in your NID. 200 is your NID. 100 is also NID. So 8 bits plus 8 bits, 16 over. In that one more I will get. So 011000100 011000100. Understand carefully, friends. This bit is also NID. Total 17 NID bits we got space. He is asking 8 subnets I want means 3 bit subnetting I am doing. So 3 bits you leave. This is a subnetting one. This is also subnetting one. This is also subnetting one. And remaining your HIDs. Now you know. Write the subnetting positions. What are your subnetting positions? We know 0, 0, 0 to 111 we are going to do in order to this problem. But before that you tell me this 100 is eligible for CIDR representation or not. This is very much important. If this is not eligible for CIDR representation, then you cannot do any kind of a subnetting in this. So before doing a subnetting, you have to be very cautious whether this is eligible for subnetting or not. Rule number 3, you're supposed to satisfy very clearly. So before you start doing 8-bit subnetting, he is asking first question, is it CIDR? If this is CIDR, then go to the second question. If this is CIDR, then do 3-bit subnetting. 3-bit subnetting is nothing but you are going to get 8 parts. So before you start doing subnetting, you check whether it is CIDR eligible or not. Otherwise, it's a cancel. Answer is wrong. You will say that it's not possible to do subnetting in this because starting number is given wrong. So let me do 17 ones, 200 point, 100 point, 100 point. So 17 ones means 15 zeros we want. 17 ones means 15 zeros because your number of HIDs, you please observe. Number of HIDs, there are 17 ones. So remaining are 15 zeros I need. Are there 15 zeros? That means what? The starting number is having a 15 zeros from right to left? Not at all. Therefore, it's not a CIDR. When it is not CIDR, don't do any kind of subnetting. It's not eligible. Now let me do the last question. I'm doing 200 point, 200 point, 0.0 with slash 17. He is asking 2 questions. Is it CIDR? It's perfectly alright. We will say yes. Why yes? 2 power 32 minus 17 1. So 2 power 15 zeros are your HIDs from right towards to left. Yes, I got zeros. So in your given IP, I got from right towards to left 15 zeros, hence it is eligible for CIDR. In that, do the second question. What is that? Do 3-bit subnetting. Please understand friends, now I am doing 3-bit subnetting. Before that, write NID part. So 17 networked bits. This is NID. This is also NID, 16 OGA. And this is. Now in this 1 bit you take, this is also NID, bus. Now remaining bits are purely for HID only. But in that he is asking you to do 3-bit subnetting. That means 3 bits are reserved for subnets this time. So take it. This is a subnetted. This is a subnetted. This is subnetted. I am doing a uniform distribution. Now the remaining part is for HID only. Please understand. Now I got 3-level hierarchy. One hierarchy is a network. Another hierarchy is a subnetwork. Another hierarchy is a host IDs in that subnetwork. 3-level hierarchy I am following. Now you know how many blocks you are going to get. So 3-bit subnetting means you are going to get 8 parts. 2 power 3 subnets you are going to get. Okay. What are the subnets? 0, 0, 0 and goes to the last. Please understand. 1, 1, 1. Remaining are zeros only. Don't change your HID positions here. So now you got the subnetted parts. What are subnetted parts? Observe carefully. Your 200 point, 200 point, 0.0 slash 17 is split into 8 parts. 1, 2, 3 and 4, 5, 6, 7, 8. So we want to identify them. What are the numbers you got? Starting number. What is the starting number? 0 only. Ending number? Please understand. 200 point, 200 point, it is a 0. What is the ending number? Please observe carefully. So 0, 1, 2, 3. What is the meaning of that? Please see. 1, 2, 4, 8, 16, 32 and 64. So these many blocks you are going to get. So what is your first block number? What is your second block number? Second block number I am writing 001 combination. Third block number 010. Write 3-bit formation so that you are going to get first 1. This is a 1, 2, 4, 8, 16, 32, 64, 128. We are not touching 128. We are doing from 64, 32, 16 only as a 3-bit subnetting, because the remaining part we want to keep it for what? HID. Out of 15, 3 bits I have given. So remaining 12 bits I am using for what? HIDs only. Now you read out the values, friends. 200, 200, 0.0. Take it. 200, 200, 0.0 slash 17 NID bits plus 3 bits you are using, right, for subnetting. So it is a slash 20. Come to the next again. 200 point, 200 point. What is the value? Listen carefully. This 0 is there as usually. And there are 4 zeros are there as usually. 1, 2, 4, 8, 16 value this is. So you got 16.0 slash 20. Next one, 200 point, 200 point, 32.0. You know why 32? Please understand. 1, 2, 3, 4. 1, 2, 4, 8, 16, 32 is on. Next one, 200 point, 200 point, 48.0. Next 200 point, 200 point, 64.0. Next 200 point, 200 point, 96.0. Please understand. 200 point, 200 point, 128.0. So 1, 2, 3, 4, 5, 6, 7, 8. One more is there. What is that? Last one. 64, 32, 96 plus 16. It is 128. So well friends, so this is how. So 0, 16, 32, then 48, then 64, then 80, then 96. One more is there. 80 and 96. 200 point, 200 point, 80.0. And everybody is using slash 20 only. So now in this, my dear friends, I shown you how to identify whether it is CIDR or not using rule number 1, rule number 2, rule number 3. I also shown you how to do the subnetting, especially in CIDR. This was the question in 2020 GATE examination 2 marks question. Exactly same, just by taking 1 or 2 digits. I am following here 200, they might follow some other digits. Clear, my friends? Before you want to do subnetting, you have to cross check whether it is CIDR or not, otherwise don't do subnetting. Once you prove that that is CIDR, then leave the NID bits, how I have shown you. Leave the NID bits. Don't touch NID bits. You need to drop exactly. Leave NID bits. These are all NID bits only. There are 17 NID bits. And remaining from HID bits, how many you want to do subnetting? As he said, the 3-bit subnetting I want. So take only 3 bits from there. Write 3-bit combination 000 to 111. Then rest of the value is as it is. Okay friends. So we'll meet in the next session. And what is the schedule? Announcements I am doing now. The schedule is a small change in YouTube classes. Tomorrow onwards we are going to do YouTube classes from 6 a.m. If you miss due to any kind of reason, but don't miss, but immediately access it and watch it. 6 a.m. is our YouTube class tomorrow, because still we are doing a subnetting. We are doing subnetting already completed in FLSM. We already learned VLSM. Now today we completed what? CIDR representation. Next session I'm going to tell you how to pull subnet IDs and supernet IDs. That means supernetting is also come into the picture. Please don't miss supernetting concept. Very important. So from tomorrow onwards, our YouTube sessions of your computer network subject is from 6 a.m. If there is any change in the next upcoming classes, I will notify immediately in the before class. And today, this is from tomorrow. This is your tomorrow schedule. And I'm going to start, as I'm saying, that tomorrow onwards 7 p.m. to 9 p.m. we are having a plus course. The subject is DBMS. So don't miss from the starting class to ending of DBMS is very important. So I'm doing full comprehensive course on DBMS, which including of practice sessions and quizzes and your previous year questions discussion. So all are included in that plus course. It's going to be very long to complete this subject. That's why attend from starting of the class. So you want to listen this DBMS classes on plus course, immediately you have to take the admission using my referral code. If you use my referral code, then you will be tagged to me so that you will be one of my student. So use this referral code. Apart from tagging, you also get a maximized discount. Enjoy the discount benefits also by using this referral code. This is for YouTube tomorrow onwards. This is for plus course on DBMS from tomorrow onwards. This is for tomorrow. What about today? Today I'm doing a 2 more sessions. One session, as usually we know, last session I announced 6 p.m. we are doing a quiz part 2. Quiz part 2 on IP addressing, very important. So last time whoever appeared, please don't miss the today's quiz. Who are not appeared the last one, please watch that lecture and come to the today's quiz session, which is on Unacademy platform only. So download Unacademy student learning app, then immediately register yourself with your mobile number or a mail. Then the session is going to start exactly from 6 p.m. I'm going to discuss around 30 to 40 important questions so that you can able to go to the next level, that is a tomorrow's quiz examination. One quiz will give you a lot of confidence to the next quiz. And 8 p.m. I'm going to do what is the importance of the scope of CSE students, the GATE examination scope of CSE students. That caption is how you can able to do easy way out. This is the caption. I think, but what are the scopes and what are the admission streams are there in IITs? Those things I'm going to discuss briefly and deeply. That session is going to start at 8 p.m. on YouTube. This is on YouTube only. So search for Srinivasrao in Let's Crack GATE CSE. This is broadcasting. Search for Srinivasrao in Let's Crack GATE CSE. And this quiz part is only on Unacademy app. Okay friends, this is a schedule announcement. Tomorrow your YouTube classes are from 6 a.m. not from 2 p.m. So 6 a.m. to 7 a.m. and tomorrow onwards 7 p.m. to 9 p.m. specialized class course started, that is a plus course. Subject is DBMS, which takes around 60 hours time. And today quiz on 6 p.m. quiz on IP addressing part 2, which is on Unacademy app. And today I'm going to do one more session, the importance of GATE to the CSE students especially, and what are the admission scope and job scope All those things I'm going to discuss in Let's Crack Gate CSE YouTube channel. That's broadcasting at 8 p.m. Don't miss. So thank you for your valuable time. Please like my video and give a positive comment and share these videos to all your friends, those who are interested to learn computer network subject, especially IP addressing concept. This is a fourth lecture in IP addressing. Please recoup the previous lectures so that you're going to have a good strength. Before coming to the quiz examination, please watch my previous lectures of IP addressing. Otherwise, it is difficult to answer those questions, very important questions. Please do like, friends, and give a like as well as give a positive comment. We will meet in evening session, that is at 6 p.m. part 2 quiz, and 8 p.m. the importance of GATE to the CSC students, and tomorrow 6 a.m. on YouTube channel, and tomorrow once again 7 p.m. on Unacademy student learning app. If you become a premium student, then you can able to watch that class. That's why don't do late. Immediately take the admission in Unacademy so that the class begins from tomorrow onwards only. Right straight away from 7 p.m. to 9 p.m. every day I'm going to do. Okay, friends. Thank you very much.